Welcome to new lecture of the uh, complex numbers. This is our second lecture actually. In first lecture we studied about the definition of complex number and its properties like addition, subtraction, multiplication and division. आज हमने पढ़ना है conjugate of a complex number. Conjugate of complex number is also a complex number, and it is denoted by the conjugate of a complex number z is equal to x plus iota y is denoted by z bar and defined as z bar equal to x minus iota y. So if we have a complex number x plus iota y, then its complex conjugate will be x minus iota y. It means we will change the sign of the imaginary part of the complex number. If it is positive, it becomes negative. If it is negative, this becomes positive. Because z and z bar both are known as the complex conjugates of each other. Now z into z conjugate is equal to x plus iota y into x minus iota y. कल हमने पढ़ा था कॉम्प्लेक्स नंबर्स के लिए कि a प्लस b iota into a minus b iota is equal to a square plus b square. So this will become x square plus y square. This thing we define new number z into z bar is equal to x square plus y square, and this is known as z modulus square, where z modulus is the absolute value of a complex number. That is, if we have a complex number z is equal to x plus iota y, then its modulus is defined as z bar is equal to x square plus y square whole square root. Therefore, z into z conjugate is equal to modulus of z whole square. So this is another definition. Z into z conjugate is equal to z mod square. Now, in next slide, we will study the properties of the complex conjugate of a complex number. Properties of complex conjugates. Now we study the properties of the complex conjugate. First property is z conjugate is equal to Z. We will prove it. Let's suppose Z is equal to X plus iota Y. Then by definition Z conjugate will be equal to X minus iota Y. Therefore Z conjugate will be equal to X minus iota Y conjugate, and this will be equal to X plus iota Y. So Z conjugate is equal to Z. This is the first property. Second is Z1 plus Z2 whole conjugate is equal to Z1 conjugate plus Z2 conjugate. You can prove it easily by taking Z1 is equal to X1 plus iota Y1 and Z2 is equal to X2 plus iota Y2, and then using the definition of addition of the complex number and then taking conjugates, we can take the prove that left hand side is equal to right hand side. Similarly, for minus, if it is Z1 minus Z2 whole conjugate, this will be equal to Z1 conjugate minus Z2 conjugate. तो इसका मतलब ये है कि पहले आप प्लस करें और फिर conjugate लें, या पहले आप conjugate लें और फिर प्लस करें या माइनस करें, आंसर दोनों में सेम आएगा. Third is Z1 into Z2 whole conjugate is equal to Z1 conjugate into Z2 conjugate. And fourth one is Z1 over Z2 whole conjugate is equal to Z1 conjugate over Z2 conjugate. So these are few properties of the conjugates of a complex number. Next we will study the properties of the modulus of a complex number. Properties of modulus of complex number, are absolute values of the complex numbers. First is, for this we can say that if we have two complex numbers Z1 and Z2, then Z1 into Z2 modulus will be equal to Z1 modulus into Z2 modulus. Means if we take the product of two complex numbers and we then take modulus of these, this will be equal to modulus of first complex number multiplied by modulus of complex number. And remember one thing, that modulus of a complex number is always a real number. Similarly, for division, Z1 over Z2 whole modulus will be equal to Z1 modulus divided by Z2 modulus. And but for addition, this equality does not hold. For addition, we say it is triangular inequality. That is Z1 plus Z2 whole modulus is always less than or equal to Z1 modulus plus Z2 modulus. That is, this is called triangular inequality. Z1 plus Z2 whole modulus is less than Z1 modulus plus Z2 modulus. It can be proved easily by taking the two sides of the triangle as z1 and z2 and then using the fact that the sum of two sides is always equal to the one side. Yes, that's it. And similarly, z1 plus z2 whole modulus is greater than or equal to z1 modulus minus z2 modulus. So if it is plus, then z1 plus z2 whole modulus is less than z1 modulus plus z2 modulus, and z1 plus z2 whole modulus is greater than the difference of z1 modulus and z2 modulus. These two inequalities are known as triangular inequalities. Next is until now अब तक हमने बेसिक प्रॉपर्टीज जो है कॉम्प्लेक्स नंबर्स की वो हमने पढ़ ली हैं. अब हम कॉम्प्लेक्स नंबर को ग्राफिकली रिप्रेजेंट करना सीखेंगे कि कॉम्प्लेक्स नंबर को ग्राफिकल कैसे रिप्रेजेंट करते हैं और आर्गन डायग्राम क्या होती है. ग्राफिकल representation of iota. देखना मुझे कि हम आयोटा को ग्राफिकली कैसे रिप्रेजेंट कर सकते हैं. We know that iota is equal to negative under root, negative 1 का under root. Let's take a coordinate system as two perpendicular lines. One is OX dash and second is OY dash. If we have a point, and this is real line, basically this is real line. Any number, for example x represented here, this is x. If I multiply this x 2 times with iota, if I multiply x with iota twice, then this will become iota into iota x will be equal to minus x, as iota square is equal to minus 1. So if we multiply x by iota twice, this will become minus x. How will we represent minus x? Minus x will be here. This is minus x. It means multiplying any real number with iota 2 times, we get a rotation of original number by 180 degree through origin, about origin. That is, if we multiply any real number by iota 2 times, then this image will be obtained, or next result is obtained, or it can be represented by rotation of original graph through 180 degree about origin. What about if we multiply x with iota 1 once, only single time, then this is obvious. This is, we multiply 2 times. If we multiply x with iota once, then it will be iota x, and iota x will be same. 2 times we multiply it, we get 180 degree rotation. If we multiply by once with iota, we will get rotation about 90 degree. So we will get iota x here. So any number iota x can be represented on this y-axis. That's why this y-axis is called imaginary axis and the x-axis is called real axis. And that's why this xy plane is also known as complex plane, because every point on this complex plane xy has one-to-one correspondence with the complex number. यानी किसी भी पॉइंट इस कम्प्लेक्स प्लेन का कोई भी ऑर्डर पेयर कोई पॉइंट ले लें उसके corresponding एक कम्प्लेक्स नंबर जरूर एग्जिस्ट करेगा. It means that's why we can represent any complex number z is equal to x plus iota y as the ordered pair x comma y. So if we want to represent any complex number here p, we will represent it by a point p x comma y in the xy plane, and we will join this by a vector op. This representation of complex number by the points in the xy plane is known as argand diagram. It is known as argand diagram. In here, this angle theta, which is made with the positive x-axis, is known as argument of the complex number, and the length of this vector, length of this line, is known as the absolute value or modulus of the complex number. Now, this theta can have many values because this is also theta. We can, if we rotate it once, then again we get the same angle. Similarly, if we rotate it twice, we can again get the same angle theta. So this argument of z can have many values. Argument of z can have many values, it is theta. But if this theta is between 0 and pi, and 0 and 1 degree, then this is known as principal argument. What is known as? It is known as principal argument, and represented it is denoted as argument of z with a capital. Is polar representation of complex number in polar coordinates r comma theta. We know that polar coordinates are represented by r comma theta. अभी हमने देखा है कि किसी भी कॉम्प्लेक्स नंबर को आर्गन डायग्राम पे हम ऐसे रिप्रेजेंट कर सकते हैं. फर्स्ट करें ये आपके पास y एक्सिस है और ये x एक्सिस है, एंड दिस इज पॉइंट p x comma y. So then OP vector will represent this complex number. Now in polar coordinates, this is, if this is theta, then this will be equal to y and this length is equal to x. From here we can get that x is equal to r, this is r is the this length, r the absolute value or modulus of the complex number, r cos theta, and y will be equal to r sin theta. Thus, if a complex number z is equal to x plus iota y, this can be represented in polar coordinate as r cos theta plus iota or sin theta. R we can write it at r into cos theta plus iota sin theta, where r is equal to modulus of the complex number and is equal to x square plus y square whole under root, and theta is the argument of complex number, and this is equal to, from this triangle, tan is equal to perpendicular over base. So perpendicular is y, base is x, tan is equal to y over x. So theta is equal to tangent inverse of y over x. So these are the equations or the relation by which we can change the complex number in the Cartesian coordinates into complex number in the polar coordinate system, and vice versa. So this is that's all for today. Next time we will solve some examples or numerical problems related to the complex number. Thank you.